Hey guys, welcome to a new episode of the Path to DevOps series. Don't mind the missing microphone because the old one broke and I'm using a new one right now. Until now, we've been trying to automate our Azure infrastructure using Terraform as infrastructure as code. And we're going to continue this pattern by also configuring the Kubernetes cluster we've created a few episodes ago with Terraform. Okay, so we're going to create two things inside of our Kubernetes cluster for configuration. One of them is the Ingress Controller for traffic management and path-based routing, and the other one is the Certificate Manager for SSL certificates so that our front-end website is secured. We're not going to do both of them in the same episode because this would take a long time and the episode would reach 40 minutes to 1 hour, and I don't want to take that much of your time and it will be tiresome for you to take up this much information. So today we're just going to do the Ingress Controller, and in the next episode we're going to do the Cert Manager automation. That being said, let's jump straight into it. I'm going to start with some errata from my side because 2 episodes ago when we created the Kubernetes cluster and the VNet, we didn't actually put the Kubernetes cluster nodes into the VNet. So we're going to do that right now and then jump into the subject of our episode. So how are we going to do that? This is simple. Whenever in doubt, Google it out. So we're going to search for Azure RM Kubernetes cluster resource and we're going to find this page right here. And if you scroll down a little, it will say that this example is basic, but if you want other more complex examples, you can go to the directory within GitHub. And that's exactly what we're going to do. It was the same link I had open previously. Yeah, and you have examples here of how you can integrate AKS with other features. And what we're interested in is we want our nodes to be on an internal network. Yeah, so if we open the main.tf, you'll see here that they create a resource group. So they have the provider Azure RM, they create a resource group, a VNet, a subnet, a cluster, and then they have this VNet subnet ID. And that's basically it. And we are lacking this right here. But also, we've created our VNet and we didn't create the subnet as a separate resource. We created it as a default subnet. You can see it in here. Yeah, so in our main.tf on the environment resources, we have a subnet block. And this will not be easy to reference. So we're going to copy and paste the same thing they did here. So I'm going to just copy the subnet resource and put it below. And I'm going to name it AKS subnet, and I'm going to give the name AKS subnet, and this will be env-vnet.name, env-vnet.resource group, and address prefix, I'm going to copy it from here, like that, and I'm going to just delete this block right here. So now we have the exact same setup they have, the virtual network and the subnet, they're referenced to one another, however, they are 2 different resources, and actually I made a mistake here. This is the envrg, yeah, there we go, this is fail-proof. And now we need to find our AKS block, and inside the default node pool, we need to reference the VNet subnet ID. There we go, and I'm just going to say Azure RM subnet, and if I delete these and I put the dot, it will show me that this is exactly my resource. So now when we create our AKS cluster, the cluster's nodes will be hosted on the subnet inside our VNet. And that's what I missed doing 2 episodes ago. But now we're fine, our code is up to date, so we can begin with today's topic, which is configuring the Kubernetes Ingress Controller via Terraform. If we think back to a few episodes ago when we were configuring our Kubernetes cluster manually, you might remember that we were using Helm in order to deploy the Ingress Controller chart and the Cert Manager. And that's exactly what we want to do right now because we're familiar with deploying with Helm. So let's ask the internet if Terraform can manage Helm charts. So if I open the browsing feature and I say Terraform Helm, you'll see that we have a Helm provider in Terraform. And that's perfect. It says here that the Helm provider is used to deploy software packages in Kubernetes. Yeah, so that's exactly what we want. We want Terraform to manage our Helm charts, but there is a caveat, and that caveat is that we need to authenticate to the cluster first. Yeah, you need a kubeconfig file. This is one of the options, obviously, but this is the one we're going to. So we need to have the kubeconfig file locally on our laptop because we're running everything locally, which can connect to the cluster we're creating with Terraform. So this means when we create the environment resource, the AKS cluster, we want to also grab that configuration and save it locally. So how can we do that? Well, the easy way that comes to mind is running the azcli command az-aks get credentials. This will download the credentials for us. And let's see if Terraform can run local command, and you can see I searched for this before, and there is this local exec provisioner. Now it says here use provisioners as a last resort or better alternatives, blah blah blah. Again, this is a how to get you started with using Terraform, and I want to show you that through scripting and a bit of thinking outside the box you can solve most of the problems you'll face throughout your career. So right now our purpose is we deploy the AKS cluster, we save the configuration of the cluster locally, we use that configuration for Helm to be able to deploy to the cluster, and we configure the cluster through Terraform. That's what we want, so we're going to go with this approach, and we need to implement it first. In order to implement the local exec provisioner, we just need to find our AKS resource. We scroll down. I already implemented it to test it beforehand so that I don't show you broken code. And you just add the provisioner local exec block, and the command will be the az-aks get credentials, the name of your cluster, which you can also call with the self meta argument .name, because we are inside the AKS resource, so you can use self.name to reference the name of the AKS cluster. Then the resource group, we have the Azure RM resource group, the name of the resource group as a resource, and then its name parameter. And then we have two more static flags, admin and override existing. And that's basically it. I ran the commands, and as you can see here, if I scroll up, it'll say that local exec executing, and at the end it says merged devshiki AKS admin as current context. So if I do a kubectl config get contexts, you should see that right now I am using this context and it's merged into my list of contexts. And I can also do kubectl get namespace so that you can see this was created recently, like 5 minutes ago, through Terraform. So that's exactly what we wanted to obtain before proceeding to running Helm commands. We now have the ability of creating an AKS cluster through Terraform and also pulling the config from that cluster and merging it in our local machine. And the next time we run Helm commands, they will also run inside the context of the cluster that we just created. Time for today's main attraction, deploying an Ingress controller with Helm through Terraform. And as you can see on the screen, we've already done that. And by we, I mean I, because I was testing this for some time in order to get it right for you guys. And now I'm going to explain exactly what code snippets I added to the existing code in order to reach this result. As you can see, the IP address that we've created through Terraform during the environment resource creation is being used by our Ingress controller right now. So that's exactly the implementation we were aiming for. We first create the Azure resource public IP address during the environment resource creation, and then during the Kubernetes configuration, we link the Ingress controller to that IP address. Okay, so let me show you how I've done that, but please pay attention because this is quite tricky, and I'm going to explain exactly what changes I've made. First things first, the environment folder. We're going to start here because we need to make some changes in order to reach the desired result. As I said, we need to link the Ingress controller that we will create with the IP address that already exists and is created in this environment, let's say, layer or folder. Okay, so first, let's say we created the Kubernetes folder. Yeah, as we have global and environment, we also need a Kubernetes folder which will contain all the configuration that Terraform will deploy to Kubernetes. And in here, as you can see, I don't have a lot of files. I just have a main, providers.tf, and then there's a tpl.yaml and the values.yaml, but I'll tell you exactly what I want to do with those. Providers.tf, this is quite simple. Yeah, we're deploying to Kubernetes, so we need two different providers. We need the Kubernetes provider and we need the Helm provider. Both of them sourcing their configuration from kube/config. Okay, this is straightforward, and you'll find this file on my GitHub account, link down below in the description. Then, what exactly is this Kubernetes layer going to do? Well, first things first, we have a new resource. We haven't encountered this before in Terraform, but it's called a null resource. Yeah, and this basically implements, as it says here, the standard resource lifecycle, but it does nothing. Yeah, so you're not actually deploying a resource anywhere. You just do something. And what is this something? Well, we're going to use the local exec provisioner in order to run a local command. And in our case, we're going to run helm repo update. So we're going to update our list of Helm repositories. So if I do Helm repo list, you'll see here that I already have declared two repos, the Ingress NGINX one and the JetStack where the cert manager exists. Yeah. So when we run the Helm repo update command, we're actually pulling the latest versions of all charts in these repos. Okay, that's basically the gist of it. Now, after this, we also want to be creating a resource of type Kubernetes namespace. So we're actually creating a namespace inside our Kubernetes cluster, which is called networking. This is the name of the namespace. This is the name of the Terraform resource. Don't confuse these two. They have the same value, but this is the actual name of the namespace, while this only exists in the context of the Terraform state. But nonetheless, networking will be the name of our namespace. And then we want to create our Helm release of the NGINX Ingress resource. This is going to be its name. This is going to be the namespace we're deploying to, and it's exactly the namespace we created previously. We give it the link to the repository so it can pull the chart. We also reference the chart. And then we also say that we want this values.yaml file to provide configuration. Okay, so first of all, you need to make sure values.file exists. Yeah. Then what we need to do is also configure the Ingress controller to use the IP we created during the environment resource creation. Okay, so these are two different, the Kubernetes, the environment, and the global. They are actually three different Terraform runs. Okay, so passing information from one to the other needs to be done explicitly. It's not like you can directly reference IP.value. That's not going to happen. So the way I thought about it is the following. We're going to have this tpl.yaml, which will contain the skeleton or the blueprint of the values we need to provide to our Ingress controller. And this is fairly simple. We have controller service, one annotation, which basically says Azure Load Balancer resource group. So in here, we need to tell the Ingress controller what's the resource group of the IP address that we're going to use. Okay, that's fairly simple. And we have this template here because when we run Terraform, we want these placeholders to be replaced by the actual values of that specific run, and they will be exported as a new file called values.yaml, and it will look exactly like this. And now when we run Kubernetes as a layer, as a Terraform run, this Helm release will be able to source the values.yaml file and deploy the Ingress controller for us. And also I wanted to add some depends on. This is lifecycle management. Yeah, I want the Helm release to be created only after the update Helm command and the Kubernetes namespace were created. Yeah, so this should be the final step. These two should come first, and then this will be the third, which is why I added the depends on. Now this is fairly simple for the Kubernetes layer, but as I said, we need something to give values to this tpl.yaml. And what better place to take the resource group name and the IP address than the environment layer where we are actually creating them. So let's see what changes we made to the environment layer. First things first, you can see we have a simple PowerShell script here, nothing too complex. It's a PowerShell script which takes in two parameters. One is called pip, public IP address, and the other one is called rg for resource group. Then we declare a variable called values, which gets the content of tpl.yaml inside of the Kubernetes folder. So basically, this variable called values will contain everything inside of this blueprint YAML. After that, we will do a replace. So we are going to $values. So inside of the values variable, we're going to do two replaces. First, we're going to replace the placeholder of pip with the value of pip. And then we're going to replace the placeholder of RG. Yeah. So this and this are going to be replaced with this and this. And afterwards, we are going to output everything as values.yaml. Yeah. So we take this as input, we make the replacements, and we output this. Okay, fair enough. Also, we force so that we overwrite the existing values.yaml and we give it the UTF-8 encoding because that's what we need to use. All right, fair and simple. And now we also need to make small adjustments to the main TF file in the environment folder so that it can pass down the pip and the resource group to our script. Okay. So I minimized all the resources that we don't need to look at because we didn't modify them. So if we scroll down, we see the first one, and it's a new resource. It's actually a role assignment. So we need to give the Kubernetes cluster access to the resource group that we're just creating, the environment RG. Yeah. So in our case, if we look here, it's going to be the dev RG. Yeah, we're creating the dev RG through Terraform, and it will contain these resources, but we also need to give this Kubernetes cluster permissions over the dev RG so that it can read the public IP address and assign this public IP address to its ingress controller. Okay, and if you look at access control and role assignments, you'll see that we have this network contributor role that we're assigning to the managed identity of Kubernetes. Okay, so this is done through this resource. Resource Azure RM role assignment AKS to RG. We give it the scope, and the scope is going to be the ID of our resource group, which we've created here. The role definition is network contributor, and the principal ID is the Kubernetes identity principal ID. This is fairly simple. Then we also made a small adjustment to the public IP. We need the public IP to be standard because the load balancer and the IP address need to have the same SKU. And previously we didn't specify the SKU, and this defaults to basic and it will break your configuration. So we need SKU to be standard. Okay? And the final part, which basically is the magic that binds everything together, is we create a new resource of type null resource at the end, and it's called ingress values. And in here we have a provisioner of type local-exec, and this is no longer necessary. So we have a provisioner of type local-exec, and we run a command which is basically the path to this get values ps1 file, as you can see here. And then we give it the public IP, which can be referenced like this because we are inside the same run, so we can actually call Azure RM public IP.example.ip address, and then the resource group name, which also can be called like this because we are during the same run. And after we've passed this command to the local exec provisioner, we've also added some depends on. Okay, so we want to run the ingress values only after the public IP was created and also the resource group was created. Yeah, so this should be the final step because otherwise we won't be able to give the IP address and the resource group if these two are not created prior. So once all these changes have been made, we're able to pass valuable information from the environment layer into the Kubernetes layer. And when we run, we will obtain exactly this. Yeah, so basically full configuration of the Kubernetes cluster with the Ingress controller, and it will look exactly like this. Yeah, you see we have, let's move this lower, we have an NGINX Ingress controller release deployed from the Ingress NGINX chart. That's up and running. All right, and that's basically what we aimed to do in this episode. We are now able to control and automate the deployment of an Ingress controller into the Kubernetes cluster that we've created through Terraform. So ultimately, our goal is to push one button and have all our infrastructure deployed and configured for us to use. Okay guys, this was it for today. I hope the explanation made sense, and if it didn't, just make sure you look at the example code, which you can find in the description down below, or take your time to revise the explanation that I've provided in this video. Okay, so we have 1 or 2 more videos up until the end, when we will have a fully functional and automated deployment through Terraform of all the resources that we need, plus the Kubernetes configuration, and then we can directly ship our application into the cluster and it will be publicly exposable and we will be able to consume it directly. Yeah, so pretty much press a button, grab a coffee, and your app is available on the internet. That's the dream of any automation engineer. So thank you for giving me your time of the day, and I wish you a great day wherever you are. I'll see you in the next video. Cheers. Have a good one.